Alright, for 7 inverse trig functions, so we're finally going to figure out how to use the second sine function in our calculator, the sine to the -1 option that we've seen and some of you have tried to use, not correctly yet because we haven't learned about it. Here's where we're going to learn about it. So inverse sine is defined as arc sine, and we can also write arc as sine to the -1, as you see right here. And what that means is I'm going to tell you the ratio, you tell me the angle. Alright? So, for sine, we only work with the angles that are in quadrant 1 and quadrant 4. We're defining our output as between -pi/2, which is down here, up to pi/2. And the reason why is that in quadrant 1, sine is positive, and in quadrant 4, sine is negative. So we have all the different positive and negative options that we need here. Alright, so for A, we're going to look on our unit circle and figure out where is the y value, because remember sine is the y value. What angle gives us a y value of -1/2? So here we go. We're only looking in quadrants 1 and 4. Y value for -1/2, here we go, we've got it. It's 11 pi/6. And so that's going to be our answer. We're going to give our answers here in radians. Could also do them in degrees. It didn't tell us which one to do, but it does, if you're not sure, the range is in radians. So usually we're going to put these in radians. All right, let's do the next one. Inverse sine. So we're trying to find the ratio is √3/2 and tell us what angle gives us a y value of √3/2. Let's go to the unit circle. Looking for a y value of positive √3/2, and there it is, 60 degrees or pi/3. So our answer here for B would be pi/3. All right, last one, the inverse sine of 2. Let's go to our unit circle. Notice that the biggest that the y value can be is 1. The smallest is -1. So you'll see here that x has to be between -1 and 1. 2 is too big. Can't have that. And another way to think about this, remember sine is y/r. In a triangle, r has got to be the biggest side. So there's no way for you to have a ratio of 2/1 where the y side is bigger than the r side. So we've got no solution here. This is undefined. Undefined is what we want to put as our answer. Alright, so I would like you to try to tell me, after doing that, what the arc sine of 1/2 is. Go ahead and look at the unit circle. Try to tell me the angle when the ratio for sine is 1/2. Alright, so sketch a graph of arc sine of x. And we're just going to go ahead and take this. I'm not going to go ahead and go through the graph of it. But the inverse of sine, remember sine looks like this, starts at the origin, goes up, comes back down. And we're restricting our arc sine to be between -pi/2 and pi/2. So we're just going to take this and flip it. So it's going to start negative and curve up to positive. That's going to be our graph of arc sine. All right. Instead of pi/2, 1, like we normally would have, now we've flipped it to have 1, pi/2. All right. So on your graphing calculator, what I'd like you to do, make sure you're in radians. Put this as your y1, put this as your y2, and sketch the graph of what you get. Restrict your domain. Remember that the x values, so go to your window and make your x min. Your x min is going to be -1, and your x max is going to be +1. All right, just graph that much. All right, so quickly looking at this. Sine, we know that we're in quadrants 1 and 4. Tangent, we're also going to look in quadrants 1 and 4, but cosine's a little different. Cosine, we're going to look in quadrants 1 and 2, because in quadrants 1 and 2 for cosine, cosine is positive here and negative here. For sine, positive and negative, and tangent, positive and negative. All right, so we never actually look in quadrant 3 for any of our inverse sine, cosine, or tangent results. So let's take a look here. Arc cos of √2/2. We're going to look on the unit circle and find where is the x value, √2/2, and that is 45 degrees or pi over 4. Where is the x value? -1. If we look on our unit circle, that's pi. All right, arctan, remember, is y over x. For 0, when are we going to have a y value of 0? And that's going to happen at 0. Degrees or radians are the same thing. And lastly, when is the tangent going to have a -1? So that's where our angles are the same, or our ratios are the same, which is 45 degrees. Since we're negative, we're going to be at 7 pi over 4. All right, that is our answer. And I'm sorry, we want the negative answer though. Negative pi over 4. We're going to be going down into quadrant 4 as opposed to spinning all the way around. Negative pi over 4, 7 pi over 4, same exact thing. All right, so now look at your unit circle. Tell me where the arc cos of -1/2 is. Okay, so if it's not on the unit circle, we can go ahead and plug things into our calculator. Make sure that you're in radians here. And if you put these in, you're going to get these answers out. Notice that if you try to do the arc cos of 2, you're going to get an error because cosine, the inverse cos, needs to be between -1 and 1. Same thing for inverse sine, in between -1 and 1. So use your calculator, see if you can figure out what the inverse sine of 0.31 is. All right, so now we're going to do some composition. So we're going to combine sine with arcsine, tan with arctan, all that good stuff. All right, so on all of these, we know that if we're doing the sine of the arcsine, remember that x has to be between -1 and 1, right, to get an answer out. If we go the other way, if we're trying to do the arcsine, then y would need to be in quadrants 1 or 4, between -pi over 2 and pi over 2. So let's go ahead and take a look here. Arctan, oh, sorry. And if those things are true, then they cancel out. Sine and arcsine cancels out. Sine, cos and arccos cancels out. So in this case, the arctangent of -5, if we do the tangent of that, they're going to cancel out. And we're just going to get -5. All right. Now, for b, you would think they would cancel out. However, 5 pi over 3 is over here. That's in quadrant 2, so we're going to need to do the reference angle of this. If we look at 5 pi over 3, that's going to be, excuse me, a 30-degree angle? What is that? 5 pi over 3. Switch back to my unit circle real quick. 5 pi over 3. Oh, I apologize, it's down in quadrant 4. 5 pi over 3. The y value is -√3 over 2. So we're doing the arcsine of -√3 over 2. All right, and so on that one, we're going to need to go down into quadrant 4. So we're going to say -pi over 3 as our answer. All right, lastly, the inverse cos of pi. Where is the x over y equal to pi? It never can be, x over r. That can never be true because pi is 3.14. The x value can't be bigger than the r value, so this is going to be undefined. See if you can figure out the sine of the arcsine of 0.3. All right, so now let's do some compositions of not the same, tangent with arc cos, or cos with arcsine. And here's how we're going to set this up. Anytime we see arc cos, we can always draw ourselves a triangle and set up the ratios. So we're going to make this our theta down here. We don't know the angle, but we know the ratio. Arc cos is 2 over 3. So cos is going to be adjacent over hypotenuse. We can use Pythagorean to know that this is going to be √5. And now we're saying, okay, this created our triangle. Now let's do the tangent of theta. So the tangent here is going to be √5, √5, not √2, over 2. Let's do the same thing with this. Let's make a triangle. So we've got negative 3 over 5. There's theta. I drew it down because the y value is going to be negative over 5, which makes this a 4. And then the cosine is 4 over 5. All right? So see if you can draw yourself some triangles and figure out 57. All right, last section here. We're going to do the exact same thing, but now we're not going to be given an angle. We're just going to be given a variable, so 3x here. So arc cos of 3x. Going to go ahead and draw myself a triangle. Cos 3x over 1. And now I can do the Pythagorean, which is the square root of 1 squared minus 3x squared, which I need to clean up as 1 minus 9x squared. So now let's do the sine of that. Sine of theta is opposite over hypotenuse. And so our answer is just the square root of 1 minus 9x squared. Let's do the part B here. We're going to make ourselves a triangle again. Arc cos of 3x, that's the same as before. So we've got 3x, we've got 1, and we've got 1 minus 9x squared. And so let's do the cotangent of that. Remember, cotangent is adjacent. That's our theta. Over root 1 minus 9x squared. Can't leave it like that, so let's clean it up. 3x, 1 minus 9x squared, all over 1 minus 9x squared. And that would be our solution. So last one for you to try here is 67. All right, make yourself a triangle, figure out all 3 sides using the Pythagorean formula, and then do the cotangent once you have the triangle. All right, any questions? Make sure to ask in class. Good luck.